Comparative Science. Good evening. So one more session on basic operations. So today we are going to discuss about multiplication. So multiplication is a fundamental operation. See, when I say the subtraction adds color to the life, multiplication are like the frills for a dress. So without multiplication, it's very, very difficult to carry on with our life operations. That we'll see little later. Now, multiplication always the groups are added. So whenever we multiply 2 or 3 numbers, we introduce the terms like product, and then we have our multiplier, multiplicand, and so on. They are the essential components. So the product of two measurements is a new measurement as far as multiplication is concerned. Like when we multiply length into breadth, we don't get any length, we don't get breadth, but we get an area. So this is a major shift the children have to understand, because when you add 2 cookies and another 3 cookies, we'll get only 5 cookies. When you subtract 3 cookies from 7 cookies, we'll get only cookies. But when we operate with the one multiplication, one length and then one breadth, we don't get length or breadth, we get a totally new term, that is the area. So this is a major shift in the understanding. So definitely our children have to be taught about it. Now, very often, whenever we have to do multiplication, we use the calculator. You know what is the first calculator when it was used? It was used in the year 19. I'm not able to show the picture of the first calculator. A huge monitor-like thing. A huge toy monkey is shown there. The toy monkey, that with the hand, with the legs of that monkey, we have to press the numbers that are to be multiplied, and then the hands will give the answer. It was designed like this. So this was the first calculator used in the year 1918, and then it was even called a monkey calculator. Okay, monkey toy it was actually. Now this was the first calculator. Now there are variety of ways in which multiplication is done. Now just to illustrate some facts, I would like to take you to another board. So in which I hope you will be able to see the screen. Are you able to see my white screen, whiteboard? Can you see my whiteboard? Yes? Prasanna madam, can you see my whiteboard? Can you see my whiteboard? Please tell me.
No, ma'am. Actually, we can see the PPT.
We are seeing PPT. We are seeing PPT.
Oh yeah, I'll show you my white screen. I'll just
please.
put up it and show my white screen. So certain things, maths is something, board is inevitable for a maths teacher. So I will go with that. So first method is the Egyptian method.
Okay.
So this method, suppose if we have to multiply 13 into 21, say. So they invented the idea of splitting it like this: 1 plus 4 plus 8 multiplied by 21. So 1 into 21, 4 into 24, 8 into. So they did the multiplication. This was introduced by Egyptians. And then Babylonian method. So that is the second thing. So the Babylonian method, what we use, they use the tables, what we use now. But that tables is not based upon the number 10 decimal system. They had their decimal 9 system, binary system, and all that were in use in that time. They said that numbers have only up to certain numbers can be made possible, and it was only the Indians who said that there is no ending for the numbers. So the numbers, whatever be the number, we can always find a greater number to it, and this was found by our Indians. Now there are several ways in which multiplication can be done. So I am going to show you one such method, that is the grid method. So this grid method is, suppose we have to multiply 30 into 34 into 13, say. 34 into 13, okay. Now the 34 can be splitted as 30 and 4. And then 13 can be splitted as 10 into 3. We have to have a grid like this. Now in this grid, the 30 has to be written first because it marks the tens column. So tens once. And here also it has to be written the same order, 30 and 3.
Excuse
So
me,
now
Rajeswari
here
ma'am.
30 tens are, and then
Rajeswari,
4 tens are, 3, whatever, any problem?
yeah, are you showing any PPT or writing?
Said, yeah, okay. Wait,
Okay, you
sorry,
haven't
please.
changed it.
I'll show you.
Yeah,
I'll just come out of it
yeah.
and then do it. Sorry if I'm taking
No, no,
time.
it's okay. It's okay.
Are you able to see my screen now?
Yes, ma'am.
Oh, so it is 30 and 4. And then here 10 and 3. So we have to split it like that. So 349. So adding everything, you will get the answer as 442.
Oh,
This is one particular method. This was also, though it was practiced in India, but anyway, it is nowadays the children do only by tables. I'll come
yeah.
to that little later. Next is the lattice method. So this lattice method is like this. So in the lattice method, what you have to do is, you have to have again the grid kind of patterns.
Okay.
So I will show you in my whiteboard. It is easier to understand. So this is, now here we have to multiply 45 into 256. Say. So this lattice method, we should have a column like this, and then we should have 2 rows, and then here like this. So this is for 256. So this is 5 and 4. I'm 45. So I'm just writing it as 5 and 4 here. It has to be written in this manner. And then 2, 5 and 6. So you should have a column here. And then here it is 5 twos are 10. It is written like this. And then 5 fives are 25. It is written like this. 5 6 are 30. It is written like this.
Yeah.
And then similarly in the down also 4 twos are 0, 8. And then 4 fives are 20. So this is extended. And then here it is written like this. 4 6 are 24. So I write like this. So from there, how will I get the answer? The 0 first. And then here 3 plus 4 plus 5. It is 12. 1 plus 2 plus 3 plus 2, 5. And then again here 2 plus 8 plus 10 plus 1 here, and then 1 plus 0. So this is your answer. So this method is, so nowadays it looks little more cumbersome and little more we might feel, but these were the fundamental, this earlier the multiplication was done like this. So after the introduction of tables, so the whole multiplication, what we use now, we use the tables, and then varieties of calculators we use, and like that we do the multiplication effectively. Okay. Now here, one more thing I would like to show you. Multiplication is always something like, it has got properties of products. Like I have told you, if you multiply length into breadth, you get area. Similarly, one can meaningfully add or subtract quantities of the same type, but quantities of different kinds can be multiplied. For example, 4 bags with 3 marbles. What do we get? 4 bags with 3 marbles. We'll get only the total number of marbles.
Yeah.
Isn't it? Similarly, when two measurements are multiplied, a centimeter and centimeter are multiplied. So we don't get centimeter is the answer. We have to get the answer as square centimeter. So this is one. Similarly, centimeter into centimeter into centimeter, that square will become cube. So that becomes what? It is a 3 centimeter cube. So this is called dimensional analysis. And this dimensional analysis is the subject of research these days. So various dimensions we analyze like this. And then a lot of theories have been found out. This is only a fundamental of the dimensional theory. A common example in physics, how the multiplication is the fact that multiplying the speed and the time. The speed and the time gives you, it neither gives you speed nor gives the time, but whereas it gives the distance. So the entire unit is kilometer. So the distance, they don't have per unit and then we don't have per 1 hour, nothing like that. It is the kilometer. And similarly, to 11 meters into seconds, that gives you the total distance. 4.5 residents, and then there are about 4 residents are there in the house, and then the 20 residents, how many people will be there? So we don't get the residents or the house, we get only the total number of people. So like that, multiplication is like that. So different procedures for different theories, so different units. That's what I will take. Now the multiplication tables. So multiplication table has got an art connect. So the children find it very, generally they may find it easy or difficult. That depends on how they have absorbed the concept. But multiplication has got a close art connect because it talks about a pattern. Now, one simple example, even though we can present a lecture on this for hours together, I would like to show a small glimpse. Now here, this is a table of 2. I have entered here the patterns in the tables. That is the heading. Suppose now I am taking this 2 times table. So the ending digit alone I have taken. 2, 4, 6, 8, 0 and 2. Or the ending digit. 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8 and so on. Now draw a circle and then mark the digits 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Now here start with the 2. 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 fives are 10. Again 2 ones are 6, 2 twos are 12 and then 7. Again the same pentagon is repeated. A circle with pentagon in the middle and then 2 here. Similarly, children can immediately get it. So this is representing 2 table. So like that for each and every table one pattern is represented. This is for 3 tables. So how do I arrive at this? 3, 6, 9, 12, 5. 3 5s are, 3 6 are, 3 7s are, 3 8s are, 3 9s are, 3 10s are. So 3 to 0, the numbers are in this arrangement, the last digit. So let us start. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15, 3 six are 18, 3 sevens are 21, and then 3 eights are 24, 3 nines are 27, 3 tens are 10, and then 3 11s are 33. So by going through the numbers, what happened? We get a beautiful pattern. So the children can beautifully draw, decorate it. The teachers can display this on the class. So definitely it is a very fun-loving and amusing activity in the table. Similarly, for 4 table also we can create a star design. For every table, there is one design that can be created. Now, another interesting art activity. Can anyone tell me what I have drawn here on this board? This is also based on multiplication, just a clue. Can anyone tell me what are all this? You may say symmetrical shape.
Yeah.
One is the mirror image of the other. All these things, okay. It has got a specific name. This particular pattern is called this, a specific name has been given to this particular shape. Can anyone name? Okay, no problem. They are called spirolaterals. Yes, spirolaterals. Spirolaterals. How to get the spirolaterals? Again, we have to go back to the table only. Here I have listed the table of 2. 2, 4, 6, 8. Okay. But when it comes to 2 5s, it becomes a double digit number. 2 5s are 10. Here we have to get the sum of the digits. Like 1 plus 0 is 1. Then 6 2s are 12. 1 plus 2 is 3. And then 2 7s are 14. 1 plus 4 is 5. So like that, they form the pattern like this. 2, 4, 6, 8, 1, 3, 5, 7, 9, etc. Again, the pattern repeats. So that's first we have to get the pattern. So once after getting the pattern, what we have to do? We have to start at any place on the grid paper. We have to turn to the right. The number of steps is 2. 2, 4, and then 6 steps. And then turn to the right 8 steps. And then turn to the right 3 steps. Turn to the right 5 steps. Turn to the right 7 steps. And turn to the right 9 steps. And again, this is repeated. Like that, you can come and complete the design here. And this is
Oh,
a beautiful art connection. So the multiplication table, so the children have to definitely enjoy this in the class. And they should try to create some patterns like this. This is not the only way. Every table has got a peculiar pattern like this. So
okay.
here in this side, I have shown a 7 table I have shown here. And then it is not only that they can turn in the 90 degrees. They can turn 45 degrees, we get triangular patterns like this. So the pattern and max are inseparables. From every pattern, they have to generate or generalize a relationship. And then every generalization is so unique. So these are all the ways in which we can cultivate an interest in the subject. Can do it easily. Any number 1 to 5, 1 2s, 1 3s, 1 4, 4 5, or up to 5, okay, no problem. When it goes for beyond 5, say 6, 6 to 10. So this is your 6, 7, 8, 9, 10. Similarly, this finger 6, 7, 8, 9, 10. So my 10 fingers, I have marked 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. This is the first step. Okay. Now I have to multiply 6, 6 are. So bring both the 6 together. Okay. If I bring both the 6 together, so what do I get? I have got 2 fingers. 2. How many fingers I have folded? 4 here, 4 here. 4 4s are 16. So this stands for 10. 20 plus 16 gives 36 is the answer.
Ah, oh my God.
This is one. Similarly, 6 sevens. So this is my 6, this is my 7. In this finger, this is 7, this is 6 and 7.
7.
So I will bring them close like this, 6 and 7. Okay. Now, fold all the other fingers. So how many are there? 1, 2, 3. Okay, 3. 3 tens. Now, 4 fingers folded, 3 fingers folded, 3 fours are 12. 30 plus 12 gives us 42.
My God.
Then let us go for 7 eights are. So this is 6, 7. And then 6, 7, 8. So 7 here, 8. So I'm going to fold here, fold here. So how many are there totally?
5.
1, 2, 3, 4, 5. Correct?
Yep.
Now here 3 fingers folded, here 2 fingers folded. 3 twos are 6. So 50 plus 6 gives you 56 is the answer. 5 and 6, 56. So this is for any multiplication from 6 to 10. So similarly, 6 11s are 6. So there are also finger techniques available. Now let us take the table of 9. 9 is a very, very simple thing. So again, here the total scene changes.
Yeah.
1, 2, 3, 4, 5. 6, 7, 8, 9, 10. 10 fingers. Okay. Now 9 ones are. So 9. 9 ones are 9. Now 9 twos are. So this side 5, this side 3. So how many fingers after this? Only 1. So 1 8. It is
Yeah.
18.
18.
Okay, 9 threes are. So how do we go? So this is symbol. Okay, so I'm just closing this like this. So here 5 and then 2, 7. But this is the symbolic for the 9. So how many fingers are here opened out? 37, 27.
27.
Then 9 fours are. So 9 fours are. So this I am closing. So this is the symbolism, denoting the operation. So I'm not counting here. So I'm just folding it. So here, how many fingers are there? 6 stretched. Now before this, I have to count these 3. So 3 tens and 6 ones. 36. So like that, it can all the 10 numbers up to 10 nines can be. Similarly, we can do for any table, 2 table, 3 table, 4 table, 5 table, all up to 10 we can easily do by fingers. And then what I used to do in my class, I will do it as a shadow play. So children have to have some amusement.
Okay.
So the way I keep my fingers, when I portray it as a shadow, some image will be formed. So that is the indication of that particular product and answer. Now here, before I end, there are certain applications in life. Now you open the fridge, take the eggshell, Again, multiplication is needed. Billing, and then exam center. How many children are to be accommodated? How many rows? How many columns? Multiplication is needed. And then understanding finances. And then anything involving time, we need multiplication. Suppose the distance is 40 kilometers. I can walk only at the rate of about 8 kilometers. Then how long I have to walk? Like that. It's kind of situations. And then ceiling tiles. You have to tessellate the floor. We have to find the number of tiles required. We need, multiplication table, multiplication. Pictures analyzed on a wall. So how many pictures I can roughly stick on my wall? So that's again multiplication. And then marching soldiers. So you see an array of soldiers in a contingent. How many soldiers are there? So like that, varieties of ways, various ways, everywhere we have to use the multiplication. Let the teachers have to enjoy teaching mathematics. Only then that can be transferred to the children. Because only when I am happy, I'll be able to share my happiness with you. Only when I enjoy, I'll be able to, share my happiness with you all. So the teachers have to enjoy teaching mathematics. They have to use their skills, innovations in the class. So if we do so, this becomes a very, very useful and joyful activity in the class. Thank you for giving me the chance.